Hi, welcome to Mr. Canada Maths, and we're going to do fractions to decimals today. So, these are kind of the ones that people dread a little bit because they actually have to do some work. They actually have to do division. However, always see if there's a shortcut. There are some shortcuts with division ones, so we're going to look at the shortcut method first. So, case 1 is our shortcut. So if the denominator is a factor of 10, 100, 1,000, etc., right? Or an equivalent fraction follows suit, right? Which means if by making it over, if we can make it over something like 20 or 30, then can we get back over 10 or 100, 1,000 at some point? So, uh, step 1, we want to look at this conversion of 2/5 to a decimal. So, can we find it? Can we represent it as something over 10? Okay, so can we represent this as something over 10? Well, yeah, we can. How do we get from 5 to 10? Well, we times by 2, right? So if we times the bottom by 2, we times the top by 2. We're going to find then that is 4 over 10, which we know as 0.4. Okay, so that was our step 2, was just the movement of the decimal place. So here, what about 5/8, right? So let's look at this one, okay? So 5 over 8. Well, we can't get something over 10, but maybe we can do something so we can get it over something that we can work with. Well, let's just go and just keep adding 8 until we find something that ends in a 0. Let's go, well, 8, 16, 24, 32, 40. Oh, right. So that's times by 5, right? So here we can times by 5, and that means we times the top by 5. Then we end up getting 25 over 40. Okay? So at this point, we still have to end up doing a little bit of division, but you can. I find that sometimes it's easier when we're working with a little bit bigger numbers. So here, we want to get this down to 10. So here, how can we divide 25 by 4? Right. Well, that's 6.25. So we do actually have to do a little bit of division as well. So the way I did that was I looked at the next number that I could divide by 4. I saw that it was 24. 24, right? Sorry, my pen's not working. 24, and then we're going to divide this by 4 equals 6. And then we have this 1 left over that we divide by 4, and that's equal to 0.25. Lastly, 3/4. Sometimes what you have to times by is actually quite big for the little trick. I wanted to show you that last example because you can use some of the trick to help you, but you might just choose to divide a question like that. But this one, nice and easy. We know that there's 4/25s in 100, so we're going to just times it by 25, and we'll find that we have 75 over 100, which is decimal 75. Because we've done this all before, right? So using this trick is just using equivalent fractions for the most part, and knowing that dividing by 100 will just move it twice. Okay, so that's method 1. Now here is method 2, or case 2. And if it's any value, if you can't find a 10, 100, 1,000, or find some easy trick, this works always. So if you are okay with short or long division, this method might be for you because you don't have to worry about ever finding equivalent fractions. So here we're going to set up our long or short division. So I'm going to do both for the questions, and then you can pick and choose what you like. So set up a long or short division. Numerator on the inside. So that is our 2 on the inside, and that means 5 is on the outside. So, if you know what you're doing, ignore what I've written down. If you are really struggling, you might want to, I'll read it out, and then you can decide if you'd like to copy. See how many times the number outside can fit into the inside. So how many times can 5 go into the number 2? Well, 5 can't. So if it cannot, we put a decimal place above the inside number. So right here, right above that 2, I'm putting a decimal. And then I can add a 0 to the right of my number there. Now, we've moved over, so we're not actually trying to fit into 2, we're trying to fit into the next number. So we can fit into that, because now we can fit into 20. So that's the whole point. It allows us to go into the decimal places. So we have 5. How many times does it fit into 20? Well, it fits 4 times. And we have nothing left over. So that's our short division. Our long division is 5. And this process is all the same. But 5 fits in 20. What does that equal? 5 times 4 is 20. And we have, then we subtract these two and we see 20 minus 20 is 0. So that's where that 0 and that 0 come from. Okay? So in short division, we just do all that in our heads and then put the number up there. Okay? So here, they just ask us, well, put a value, right? So we're putting 0.4. Correct? So let's look at this guy right here. So we're converting 5/8 to a decimal. So we're doing 5. I want to see how many times you can fit 8 into 5. Well, can it? No. Right? It's a bigger number. It can't go in. So what do we have to do? Decimal. You put a 0 on the outside if you want. Some people like doing that and just squishing it all together. That's fine. Now this allows us to write a 0 here. 8 goes into 50. Well, 48 is the closest, and that's times 6. So 6 times that is 48. 50 minus 48 is 2. Now, can 8 fit into 2? No. But if we add a 0, that means we're going to move to this spot. So we just keep moving. Now, 8, can it fit into 20? It can. It can fit 2 times. And what are we left with? Well, 4. Same thing. We can't fit in there, so we can add a 0. Can 8 fit into 40? Right? So this. That's what I'm looking at when I'm saying 20, 40, etc. Well, it can. It can fit in 5 times and nothing. So when you hit a 0, we are done. So we can rewrite it as 0.625. Sorry about that. So this next one, 3/4 to a decimal. So same exact thing, right? We can do 3, 4, cannot fit in, put the decimal. I like putting the 0 up front. Sometimes the decimal gets forgotten about. 4 fits into now 30. How many times? 7 times. 28, so it's a 2 remainder. So how many times can it fit into 20? 4 can fit into 20 5 times. 0.75. Always restate your answer outside of what most call the bus stop method. So it's very easy to see that this is what your answer was. Lastly, let's do this. Convert 1/3 to a decimal. So here, setting up the same way as always. Okay. So we have, how many times 3 fit into 1? It can't. So we're going to do that. Put a 0. 3 fits into 10 3 times with a 1 remaining. Can't fit into 1, so we add a 0. 3 fits into 10 3 times with a 1 remaining. 3 can't fit in there, so we add a 0. 3 fits into 10 3 times with a 1 remaining. 3 can't fit into there, so add a 0. 3 fits into 10 with a 3 times with a 1 remaining. So I did that on purpose. You can see after a while it's 0.3 recurring. So make sure when you're answering a question, you can stop after a couple. Once you know it's something that's recurring, you can just stop and say, well, I know it's recurring. I'm putting 0.3 with a dot over top, or 0.3 with a line. So just depending on who's grading your paper or what method you're taught. The 0.3 with the dot over top is mostly UK. 0.3 with the line is mostly North America. So here are a vast amount of fractions to decimals for you to do. Pause the video. When you're ready, press play and we'll go through the answers. Okay, so welcome back. First couple, we'll just state the answers. So 1/5 is 0.2. 4 over 20 can be simplified to 1. Right, we can divide by 4. 1 over 5, which is 2 over 10, which is 0.2. Right. 8 over 25. Well, that's the same thing as saying 32 over 100, which is 0.32. Next, we have 18 over 72. So I see that as being, I can divide that by 9, just to give me something simpler. Sometimes you might know off the top of your head. So 72 over 9 is 8, which is 1/4, which is 0.25. So it's handy actually to start memorizing some reoccurring ones that you see. So not recurring, but reoccurring. So 1/4, 3/4, 1/3, 2/3, right? Some common denominators that you see all the time. You might want to see how they break it up. So here, 3/8. Well, I might just opt to do it this way. How many times does 8 fit into 3? It can't. It can fit into 30 though. Was that 3 times? And we have, that's 24. So we have 6 remainder. It can fit into 60 7 times with a 4 remainder. So it can fit into 40 5 times. So 0.375. 7 into 16, or 7/16. So it cannot fit in, so we can add our 0 beside. Well, we know that 16 times 4 is 64. So we put our 4 up there. 64, we have 6 remainder. Well, now we have, how many times does 16 fit into 60? Well, it can fit 3 times. And we are left with 12, right? We have to add on a 0. How many times does 16 fit into 120? That's a little bit harder for some people to visualize. So if you're ever having trouble, right? So I know 10 would be 160, right? And then you can count back from what you know. So, or you could just guess and say, well, let's try 16 times 6. I'm going to go with 6, 3. Oh, look at that, 96. So if I add on another 16, I'm going to get 102, 112, and that will be 7 with 8 remainder, add on a 0, and then you can see that we go in 5 times, and we're done. So sometimes they'll just tell you round to this many decimals. If it doesn't, keep going, because they might want just an exact number. So here it is 0.4375. We're looking here now at 7 9s. So 9 goes on the outside. 9 can't fit into 7. So 0 with a decimal. So we can put other 0. Now 9 times 8 is 72. So 9 times 7, 63. We have a 7 left over. Add a 0. 9 goes into 70. 7 times again. So we're going to get this recurring decimal. So we get 0.7 with the dot. Or 0.7 with the line. Next one. We have 3 and 11. 11 can't fit into 3. Got it, but it can fit into 30. How many times? It can fit twice. And what are we going to be left with? Well, it's 22, so we're left with 8. We have to add a 0. 11 into 80. It can go 7 times to make 77. 3 remainder. Right? Then, what can we do? Well, we can add a 0. It can fit into 30. How many times? Well, 2 times. 7. And you can see this recurring decimal again. So Don't be scared by the recurring decimals. It's actually, I find it's actually nicer because it means we can just stop. Keep in mind, I put a dot over each value that's recurring if they're right next to each other. I'm just going to erase a little bit of this so we can get the last one done, the work. So 9 sevens. So how many times can 9 go into 7? Right, so this time, 7 can actually fit into 9. How many times? Once. I'm left with 2. So 9 can't fit in though, so we have to put a decimal, put a 0. 7 goes into 20 2 times. 6 remainder. 7 goes into 60. Well, 8 times. With a 4 remainder. 7 goes into 40. 5 times. With a 5 remainder. So 7 goes into 50. 7 times. With 1 remainder. 7 goes into 10. 3 times. Or sorry, into 10 1 time with 3 remainder. 1 time with 3 remainder. 7 goes into 30. 4 times. 4 times with a 4 remainder. Then 7 goes into 40. What's that? That's 5 times with a 5 remainder. 7 goes into 50. That's 7 goes into 50. That is 7 times. Oh, and you can start to see we have a recurring decimal. It took us a while to see that. However, 5, 7, and then that'll be 1, 4. So it recurs 5, 7, 1, 4. Make sure you put it in the proper space of the dots. Notice how they go over the 5 and the 4, because that's the string that recurs. And we're done.